Hello, everyone. My name is Doug. I'm a developer advocate with the Firebase team at Google. As a developer advocate, I get to, by my option, travel all over the world. I'm just here in DC for a few days, but in a while I'm going to be traveling through the Asia Pacific region, so I'll be hitting Hong Kong and Bangkok and Yangon and Taipei, and it's so much fun. But I can't understand a lot of what people say because I only speak English. This is actually kind of a problem for me. Everyone has to accommodate me because I speak English, which is great because most of the world does that. But a lot of times I wish I could understand what everyone else was saying in order to ease communication. I know, a fair number of programming languages. It's pretty easy for me to pick up a programming language, but it's not so easy for me to pick up a spoken language. But I'm sure many of you here today are familiar with the TV show and movie Star Trek, right? In Star Trek, one of the things they do to avoid having communication problems with aliens is they have these nifty things called universal translators. And this is ubiquitous in science fiction, right? I was actually watching Captain Marvel on the way here on the plane, and even she had a universal translator. She told people she had a universal translator. Everyone has a universal translator. And it's easy in sci-fi and fantasy because you can just write it into the script, right? Or you can just use special effects. With special effects, anything is possible. You can cover over so many technological difficulties simply by adding special effects. But I live in a real world, and there are no special effects for my life. I wish there were. But one of the things that computers are getting really good at doing now is understanding language. So for those of you who know Star Trek Next Generation, there's Captain Picard. Everyone always speaks to the replicator to find out what they want. So this is, and we've seen Google demonstrating a lot of ways that natural language processing can be very natural and very easy now. But I want to do it today. I'd rather not wait for some futuristic technology. We all have phones. I have a phone. You have a phone. We all can program for our phones. It's not terribly difficult to make a Hello World program, but it's far more difficult to make a Hello World translation program. But it's possible if you use Firebase and Google Cloud as sort of a conduit between the existing technologies that are offered by Google Cloud. So if you were writing a mobile app back in the old days, so I started writing mobile apps in 2010 with the very first Android phone, the HTC G1. And if I wanted to make a backend for my app, I had to stand up a server. This is the way everyone worked, right? So we had co-located servers and various hosting services. And it was possible to set up something, but it was kind of difficult to scale, right? You had to create a backend, fire up as many of them as you thought your app needed, and those backends would call APIs and services on behalf of your app. This is kind of a dated way of doing technology now. I mean, you can do it this way, but now with Firebase and Google Cloud, you don't have to stand up servers anymore. You can communicate entirely through Firebase, and Firebase can then, and Google Cloud can then invoke APIs and services on behalf of your app. So Firebase is Google's mobile application development platform. There's like 16 products in it, and they all do something slightly different. I'm not going to talk about the whole thing today. There's too much to talk about, but I'm going to spend most of my time talking about this side, what we call the develop pillar. So there's things like databases and compute services and hosting, everything you need to build out the core functionality of your app. And then once you've done that, you can move on to like debugging it and testing it, and then also growing your user base. But this is where it starts generally for most application developers. The SDKs for Firebase are provided for iOS, Android, and web. And then if you're writing games, so a lot of you might have a C++ engine or might be using Unity as well, those platforms are supported as well. I spend most of my time on Android and web, so what I'll talk to you today will show clips from, or show code bits from Android and web. And there's full open source repo from the project that I've built, and you can check that out later. So this is basically the system diagram of what I built. There's a fair amount going on here. If you've not worked with Google Cloud Technologies before, this might be a little bit weird, but that's okay. I'll break it down to you. Basically, the way it works is I will speak into my Android phone. There's a broadcaster app. I will speak into it. Language will get translated throughout Google Cloud Services, and then out the other side, a translation will appear. And then you can use that app. That's a web app, and at the end, we'll demo that, and you can see how that works. So the first thing I used in my app to get this connected is Firebase Authentication. So Firebase Authentication basically lets you log users in, and they all get a unique user ID. Now this is important because you can use this unique user ID to restrict who can read and write what data in other Firebase and Google Cloud services. You can give each user a personal space to work with. So if you're using a database, you can make sure that only people can read and write the documents in that database that they're allowed to work with. Same thing with cloud storage. You can create your own audit trails if you want. So Firebase Authentication is the entry point to get users into your app, identified, signed in with that unique ID. Now, Firebase supports several different authentication providers, so you can log in with Facebook, Google, Twitter, GitHub, email and password. There's also phone authentication. You can also create your own authentication providers. So for example, a lot of people in Japan use something called Line, and one of our partners has created a connector between Firebase Authentication and Line, so you can log in to a Firebase app with your Line account. So I'm an Android developer, so I'm going to show you a little bit of Kotlin here. So I do all my Android in Kotlin now. Kicking off an authentication flow is super easy. This is all it takes. This is all the lines of code it takes. Now, the magic here is in this library that we've built called Firebase UI. So that's the auth UI part right there. Auth UI is doing all the hard work of creating a sign-in flow. Basically, you say auth UI, start an activity, do the login. It will log in the user, and then at the end of that, the activity will generate a result, and all you have to do is check to make sure that the user logged in okay. That's all it takes. It's just a few lines of code to get started. If you wanted to build your own sign-in flow, it's actually really hard, really hard to do that. Auth UI makes that super easy. So you can see how that works in my app in the GitHub repo. So once you have users signing into your app, going in through Firebase, you want to store data about that user, about what they're doing, and I can use Cloud Firestore for that. So Cloud Firestore is a Google Cloud product, and Firebase has built APIs on top of that, so you can read and write the database directly from your app. So with Cloud Firestore, the data is all cloud hosted. So the cloud is the central repository for all your data, not the device, although there is a local cache for documents that have been stored temporarily there. It's NoSQL, so there's no selects, there's no joins. You're going to have to use NoSQL data modeling in order to get data in and out of Firestore. It's also real time, and this is the fun part about Firestore. When you're listening to a document or you're listening to a query, you can receive updates to that in real time. So you don't have to pull the database if you want to know if something changed. So you can attach a listener to a document, you can attach a listener to a query, and if anything in any of those documents change, you'll be notified immediately. That's really powerful, and I'll show you how that works later on. And if you're accessing this database directly from a mobile client, there's things called security roles that let you determine who can read and write what document in the database. Now, Firestore requires you to structure your data in a particular way. The structure works like this. At the top level, there are collections, and collections are just containers for documents. They don't do anything else. Within that, there are documents, and each document must have a unique user ID. And then within documents, there are fields, and those fields are flexible. You can name them anything you want. They can have data that could be strings, integers, references to other documents, binary data if you want to. And then the way you query it is you're basically looking for documents with fields that contain values of interest, or you can get the document by its ID. Now in my app, when I go to record voice, so again, my app is going to record my voice. What it's going to do is going to store some metadata about that recording in Cloud Firestore. So here all I'm doing is creating a Kotlin data class. I call it recording, and just set all the properties within that. So this is basically creating a POJO, a plain old Java object, which I'll store in the database. And then to write that into Firestore, all I have to do is get the Firestore singleton instance from the SDK, reference the collection I want to store it in, create an empty document reference to that, and then just call set on it. And that's it. That's all you have to do. That writes a document directly into the database. Now, it's automatically using reflection to find all of the properties from that data class and populate those as fields in the database. It couldn't be any easier, right? You know, with the way we used to write mobile apps, we had to send everything through an API server. You had to create some middleware that would take a request and then do something on behalf of that. With Firestore, it's different. You're reading and writing the database directly, which simplifies a lot of your client code. So this is what it looks like in the Firebase console. So you can see there's 3 columns. On the left-hand column, there's a list of collections. I only have one collection here called uploads. In the middle column, there's a list of all the unique document IDs. And if you click into one of those IDs, you can see the fields within that. So after my document is created, I'll have a new document, and it'll have all the properties that I set in it, plus some additional metadata. So that's good. I have metadata about my speech, but that's only getting me halfway there. Presumably, I've recorded some audio, in an audio file, some binary data. I need to store that somewhere as well. Now, Cloud Firestore really isn't the best place to store binary data. I think it's far better to use cloud storage for binary data. Cloud storage is basically object blob storage. You put bytes in and you get bytes out. It's kind of like it's a big bucket full of all of this binary information. So with cloud storage for Firebase, you can upload and download directly from the app, just like Firestore. So you have an SDK that reads and writes the bucket directly. You don't go through a middleware server. It's robust, so all of your uploads and downloads automatically resume and retry in the case of bad connectivity. And we all know mobile devices generally have very bad connectivity, right? If you drive into a tunnel, you lose connectivity. If you switch between towers, if you're in a part of the world that doesn't have very good connectivity, you need the SDK to be able to respond to those, and that's what Firebase is really good at here. It's also secure, so all of the data going into and out of cloud storage is encrypted in transit and at rest, so you don't have to worry about man-in-the-middle attacks. And the mobile access is controlled by security rules, just like Firestore. So you can restrict who can read and write what files you've already uploaded to cloud storage. So in my app, I want to take this binary data and stick it into cloud storage. Well, the first thing I'm going to do for that is get a singleton instance from the Firebase Storage SDK, build a path to that. So my path is going to be uploads, and then the unique user's user ID, and then the ID of the document that I created earlier. And then I'm just going to call put file, and that's it. If I have a file already saved to disk, which I do in this file called recording file, all I have to do is call put file, and it handles the rest. Everything else is automatic. I don't do anything, except maybe listen for a result. So now I have metadata in Firestore that I can query, and I have binary data, audio data in cloud storage. So we've sent everything up into the cloud. We've used the Firebase SDKs for that, but we still have to get this speech recognized and translated. So what I need to do is find other APIs and services to do this for me. Firebase doesn't really offer this, but Google Cloud does. So with Google Cloud, you have a Google Cloud Speech API, which will look at an audio file and pull the text out of it as long as you tell it what language it's been spoken in. And there's a translation API, so you can take that translated text and then pass it off and get up to 70 different languages translated from it. So this is what I've got so far. Now it's tempting to say, hey, maybe I could just call that Cloud Speech API directly from my device, and you could do this, but I don't recommend this because you would have to bake a service account into your app. And that service account is basically giving you full access to your Google Cloud resources. And these resources are billed. So you probably don't want anyone reaching into your app, getting a hold of this service account, and invoking build APIs without you knowing. That's kind of a bad deal right there. So I wouldn't do that. Instead, you do need some backend component here. And it's not going to be a server that you stand up. That's the old way of doing things. Instead, you can use Cloud Functions for Firebase. Now, Cloud Functions for Firebase is a serverless offering. If you know that term serverless, it's kind of a buzzword these days. Basically, you can run backend code without actually having to stand up or manage servers at all. So with Cloud Functions, you deploy code that responds to events within your project. And I'll say more about that later. It runs in a fully managed Node.js environment, so the Firebase tools support Node.js. Cloud Functions as a cloud offering also supports Python, Go, Java and Alpha, and one other language I can't remember offhand. But the Firebase tools are biased towards Node because that's where we figure most developers are going to be. With Cloud Functions, you pay for only what you use. So if you're running code, if you deploy code and it doesn't run, you don't pay for anything. The cost is zero. You only start paying for things when that code is invoked. And you're basically paying per invocation, and you're paying for how much CPU and memory you use. And that's it. So if you use nothing, you pay zero. If you use a lot, the system will scale up for you and then scale down for you. But you don't have to pay for server instances running 24/7. And it's secure. So the code you deploy to Cloud Functions cannot be directly accessed by any other client other than direct invocations through HTTP. But the code itself is locked down and secure. So if you have special logic in your app that you don't want anyone to see, deploy it to Cloud Functions. It's better than leaving it in the app, which can be decompiled. So I mentioned that Cloud Functions triggers trigger in response to events that happen in your app. Well, what are some events? Well, Google Cloud defines, of course, HTTP endpoints. You can invoke an API that you create directly. Any file that gets uploaded to Google Cloud Storage, you can have a function trigger in response to that upload. You can send messages to pub sub topics. So if you know Google Cloud Platform well, you know that pub sub is a messaging system, and you can have functions run in response to messages that are getting sent. You can also respond to documents being changed in Cloud Firestore. So now you can see this is pretty powerful, right? You can invoke code simply by things happening in your project. And these things could already be happening, and you can just tap into this series of events. Now, these are all offered by Google Cloud. Firebase goes a little further and adds some more triggers. So if anything happens in real-time database, real-time database is the sort of like the spiritual father of Cloud Firestore. It's another cloud-hosted NoSQL real-time database. Any users that are created or deleted in Firebase Authentication can trigger. Conversion events in Google Analytics can trigger. If your app crashes, you can have some code run. And there's a bunch of other, I won't go over them all. Scheduled events is actually the newest one. You can write essentially a cron schedule and have your function invoked periodically along with the cron. So this is all very, very powerful stuff. I actually like working with Cloud Functions a lot. It's genuinely very fun. And I love the fact that I don't have to like create server instances. The servers are created for me. That's the best part. So we have, what I'm going to do is write a Cloud Function that responds to my audio file being uploaded to cloud storage. So if you remember, we're writing metadata to Firestore. We're writing audio data to cloud storage, and I want to have that function pick up that audio data, then directly invoke the Cloud Speech API, which is going to read the file out of storage and give me the translation. Then I'll request translations from the translation API. So this is what I want my function to do. My function is going to automatically see that something is uploaded in cloud storage and go off and do all the busy work of transcribing and translating. And then I'll write the results back into Firestore, back into that same document that has the metadata. So what does that look like? Well, let's see. So Firebase offers an SDK. We call it Firebase Functions. That's not a really great name, but you can import this library, and then you can start to build function triggers. So on screen right now, we're defining a trigger called onRecordingUpload. And what this is saying is, hey, Functions SDK, in my default storage bucket, when an object has been finalized, let me know. Call my function. I'll know which file has been uploaded, and I'll have some extra context about that transfer. So there's plenty of code in here. I'll break it down to the most interesting bits. First thing I'm going to do is look at the path of that file that's been uploaded. The interesting thing in there is the document ID, the trailing part, the third part of that path is the document ID. I need that document ID so I can write back into Firestore. Then what I'm going to do is use the Firestore SDK, reach into the collections, reach into the uploads collection, reference that document ID that I know is there, and I'm going to get it. When I get it, then I'll have all that metadata that I wrote in there before. And I need that metadata, the language it was spoken in, the sample rate and the encoding. I need that all to pass to the Cloud Speech API. So then I need to call the Speech API. So I can import that into my app, create a new speech client, and then basically handed all the data that was received from Firestore. So it needs to know the language, the sample rate, and the encoding. And then that URI there, that's a URI that points directly into cloud storage. That gs://, that's a cloud storage URL. That's saying inside my bucket with the path that was given to me, you go read that file directly. I don't have to read it. The API is going to read it for me. So the speech API is, I'm going to invoke it with the recognize request, and it's going to give me a transcript. Now here I've simplified it. You should never index into an array if you don't know its size. I'm doing this here just for simplicity. I know that if it's successful, the recognize response is going to have an array with a length 1, and so on and so forth. Eventually, I can build that transcript. That's going to be the text of the speech that was gotten out of the file. Now I need to translate it, so I can import the translate API. And I can call this as many times as I need to get translations for that transcribed text. So I'm going to iterate, I think in my app I do it like 10 to 12 times for a bunch of common languages. And I'm going to have all of these translations in memory. Then I'm going to do some JavaScript to basically reformulate that. I'm going to associate a language ID to a translated string. And I'm going to write that back into the same document that contained the metadata. And so you can see it's not very many lines of code. I've simplified it here a bit, but the process is pretty straightforward. And then at the end of the day, we're going to look at that original document that was written. There's going to be a new field in there called translations, and it will have all the translations from all the times that I invoked all of those cloud APIs. Okay, so this is our system diagram again. We have an app that uses Firebase to write data into cloud storage and Firestore. Then Cloud Functions is going to invoke in the back end, take that data, and do all of the busy work of translating and transcribing. Now, the question is, we still need to get these translations onto other devices, right? The whole point of a communicator is that you go in one side and you come out the other. We need to still figure out how to get this onto your devices. I'm going to speak into my device, well, to my emulator, and then hopefully if the demo goes well, you're going to be able to hear translations that you want to hear. So how do we get that data into your devices? Well, what we can do is read it directly out of Cloud Firestore. And it turns out I built a little tiny web app for this. So what I have is a web page that's going to listen to Cloud Firestore, wait for new translations to appear, and then speak them on your device. So inside that web page, there's a few lines of code that works with Firestore. So what I'll do is grab the Firestore singleton instance, reach into that uploads collection, and then what I can do, if I want to know the most recent document in that collection, I can just order it by the time created field. I can limit it to one. I only want the most recent one, and I can get it. And that get will say, okay, if there's a document there, I'll get a hold of it. Now, this is fine. This gets me the latest document, but it's a one-time only request. As I mentioned before, Cloud Firestore is real time. You can listen to queries, and if the results of that query would change over time, you get notified. This is what I want. I want it to always tell me what the latest document is in there. I don't want to just get it and keep polling for it. I want to always know. So what I can do is I can take that get and turn it into an onSnapshot. So what onSnapshot lets me do is give it a function that will get called repeatedly as this query changes. So anytime there's a new document that would replace the old one as the newest document, I can know about it and I can act on it in the client. So what I have here is a pretty straightforward but simple system that lets me do universal translation. If I speak into one end, I can get the translation out the other end. Now, I've talked about how to build it. The building is pretty straightforward, but how do you scale it, right? If this to go viral, and it wouldn't because it's not a very polished app, but how would you scale it if you needed to go viral? Well, in this case, you do nothing. There's absolutely nothing to be done. Once you've built it, and you've built it correctly, it scales. So how does Firestore scale? Well, the database scale is said to be massively scalable. So you can put basically, billions, trillions of documents into a collection, and it won't skip a beat. That's not a problem. It will automatically index, and any query that uses an index will be fast. Well, how fast is it? Well, the queries scale with the size of the query result set. What does that mean? Well, that's kind of a strange way of putting things. Basically, it says, if you make a query against a collection with 1,000 documents, and you want 50 of them, that's going to scale in the same way as a query for 50 documents in a collection of 100,000, or the same as 50 documents in 100 million, and so on. The size of the collection doesn't matter at all. It's the size of the result set that matters. This is what we mean by massively scalable. And you don't do anything to create this. It just happens if it's already indexed. Worst case is that you might have to create an index for your particular query, but you worry about that at the time you develop, not at the time you go to scale. In fact, Firestore will not perform an unscalable query. It is literally impossible to do so. The SDK will give you an error message saying, look, you've tried to do a query that's unindexed. Click this link to go make the index. It's the most actionable error message ever. It's literally telling you, click this link to make the index that you need. And that's all you have to do. Once the index is created, then you can perform queries. So cloud storage, how does your storage bucket scale? All that binary data we're putting in there. Cloud storage scales at exabyte scale. So what is an exabyte? Well, an exabyte is one with 18 zeros after that. Do you have a sense in your mind about how big that is? Like, I don't. That's like cosmic scale. I don't even know what 1 with 18 zeros feels like. So I did a little math. It turns out it's 1 million terabytes. So think about how big a terabyte is, right? We're looking at hard drive size. Well, think of 1 million hard drives. I don't know. I still can't imagine what 1 million maybe you could fill up this room, maybe 2 rooms with 1 million hard drives. More practically speaking, it's trillions of high-res photos. So if you think about this, what you can do is every person on the planet can store 1,000 high-res photos in your cloud storage bucket. Now, if your app needs more than this, talk to me. I really want to know what your use case is. You should not be exceeding this anytime soon. So it should scale, especially if you're only just writing tiny little audio files in there. Cloud Functions for your backend, how does that scale? Well, it automatically scales up and down. So like I said, you don't stand up and tear down server instances. You just deploy code, and that code will scale up to individually contained server instances, and then back down to 0 if you're not using it. In fact, you can have up to 1,000 concurrent server instances for each background trigger. So that storage trigger I wrote earlier, that can be concurrently processing 1,000 requests for transcription and translation, which is a fair amount. We haven't found anyone, well, I haven't found anyone who's shipping an app that needs more than this. For HTTP type triggers, it scales a little bit differently. It's gated based on bandwidth and rate limited scaling. So you can read more about that in the documentation, but it's a fairly large amount of scale. You don't really have to do anything to get the scale. It just happens automatically. Okay, now it's time for a demo. So I need you all to take out your laptops and your phones and go to this first URL up here. If you don't do this, the demo is going to be really boring because there will be no speech coming out the other side. And the source code is down here if you want to look at that. So what I'm going to do is while you are loading that up, I am going to fire it up in an emulator. Oh, sorry. Yeah, let me put that back on the screen. There we go. This is the thing I always forget to do. I need to let it record my host. Actually, I'm going to use a headset too, because I find that when things echo, speech translation gets kind of hairy. All right, you all have it loaded up. You're waiting for your big transmission from the internet. Be sure to choose a language that you want to hear it in. I'm going to say it in English, so it'll be boring if you have it repeat back in English, but it's up to you. Okay, let's see how this works. Hello, and thank you for inviting me to this DevFest. Oh, I put it in German. It's not going to work at all. So it's going to be a terrible translation. Do I have internet? Not too bad, actually. Let's try this again. Testing, testing, 1, 2, 3. I hear a lot of English out there. Is that the best you could come up with? Let's see. I always like to try some Japanese. Let's see. Anata wa biru ga nomitai desu ga? Sometimes it's... I meant to say, would you like to drink beer? But apparently my Japanese is poor. Would anyone like to come up here and give it a try? In a language that's not English? One of these languages? Anyone? Anyone? This is your chance to test the system. Oh, we have a volunteer. Oh, you can go next. We'll do anyone who wants to try this. Within the time allotted, of course. What language are you going to try? By the way, what's your name?
Fatima.
Hi, nice to meet you.
Hindi or
Hindi? Okay. Now I'm going to push the button and you speak into it. All right.
ये इवेंट अच्छा चल रहा है.
You might have started talking too early.
Okay,
We'll see. We'll see what happens.
Do it again.
We'll see what happens anyway.
Uh-huh.
Oh, the event is going well.
Yeah.
All right, thank you.
Cool, thanks.
You, sir, would you like to give it a try? Oh, okay. That's good. That's more than I know. I only know the one. So, all right, here we go. I'll push the button and you talk.
आपका नाम क्या है?
All right, thank you. Anyone else? Someone test the system for me. You started to get up. Okay. Well, if no one else would like to try, are there any questions? Yeah. So how does it compare to AWS AppSync? I've never used any of the AWS mobile development tools. Sorry, I can't really give you a comparison. I mean, I don't know. I'm biased. It might be better. I don't know. Yeah. Yeah, well, like I said, I haven't tried any of the AWS offerings yet. I'm sure they're roughly comparable. I don't know, Firebase has been around for as a platform for 4 years now, almost 4 years now. So there's been some time to sort of refine that story. But it's good to have competition. So sorry, I haven't tried it myself. Okay.
So we're using Firestore with the Lambda functions going directly to our database. We're using an offline first approach where we store it locally and then it kind of syncs in the background. We are running into some issues. That being said, what do you propose for an offline first approach? I mean, this is the translation for where it needs in real time. Let's say you're doing some transactions. Then would you propose storing it in a local Firestore or a SQLite? Or what would you based on some of the experience?
All right, so that's kind of an involved question. Basically, is what's the recommendation for offline first apps? Firebase isn't really real-time database and real-time database, Cloud Firestore, and Cloud Storage are not really offline first. They're online mostly, offline occasionally. So when you're offline, you can read and write the database, and that's fine. But if you fired up the app for the first time and you're offline, you're not going to have any data to query. All of your queries are going to come back empty. You can write into the database, and that will eventually be synced, but it's not meant for offline first, exactly. So we can talk more about that later. Yeah.
Yeah, if I'm using on the front end on apps hybrid React Native for the different platforms, and then Firebase is on the back end running the whole app, is there any kind of disadvantage of that? Would that work well for any scenarios in which case you wouldn't recommend front end using React Native with the whole Firebase tool in the back end?
Well, I know a lot of people are using React Native. There's a JavaScript SDK. You can use the web SDK with React Native. And I see it all the time on Stack Overflow. People ask React Native questions. And I've never used React Native in my life. All the web development I do is all just straight vanilla web. But I know that people are using it for React. And I think you should give it a try and see if it works for you. Mm-hmm. Yeah.
So I have two questions. Number one is, so in order for app to work, it has to be connected to internet, of course, right? So is there a feature what if your app is not connected to internet and you still want to provide some functionality in it? So is it like Firebase supports that all these features will run locally and whenever it becomes available, it's going to upload? Or
Yeah, so that's similar to her question. So Firebase is not really meant for offline first. It's meant for offline mostly, offline occasionally. But when you're offline, you can read and write the database, and those writes will accumulate in a local cache, and then it get eventually synced. So you don't have to worry about that. But if the user's never logged in, you can't write documents on behalf of a user that never logged in. You can't verify their identity without also being logged in. So you might have a problem using it in a pure offline sense, especially if you want to use authentication.
and let's say we have an app that is on the traditional architecture that is using some middleware and then calling the server, and we want to migrate into Firebase. So is there any tools available, or can we do both? Like, can we do, let's say, partial migration, like build new feature on Firebase and still running the old system?
Yeah, so the question is, if you already have a traditional architecture, how do you move that, or can you do hybrid? You can do whatever you want. So there are SDKs for both mobile clients and also servers. So if you want to write your own middleware piece in Node.js, there's a Node.js SDK that you can read and write Firestore directly. In fact, I've even written a blog on exactly that. So if you search for, should I write my what is it? Should I write my cloud fires? Oh, there's a picture of me. Look at that. I had a blog. Oh gosh, I just posted this last or 2 weeks ago. Anyway, You can create your own REST-like web API and power that with Firestore if that meets your need. Other needs are better met with directly querying from the client because you have a local cache to work with. If you go through middleware, there will be no local cache. So you have to determine for yourself, is direct access better? Is hybrid access better? There are ways of figuring it out, and the blog should help you run through that. So, yeah, gentlemen, yeah.
My app subscribes to Firestore changes, but my users, they start the app and they depth in their pocket. So it seems like they don't often depth the changes. What do you think is the best way for them to sort of do a refresh of that data or get the changes they should have gotten when these Firestore different subscribers?
So we might have to talk about that. It depends on how you've written your code. It'll take probably more time to tease the specifics of that out than I have here, because I only have like a few minutes left. So.
In general, do you kind of suggest sort of reloading, or are there kind of ways to get those Firestore changes?
Well, so the way Firestore works is if you're listening to a query or listening to a document, there's no refresh. You're constantly being refreshed. So if you do a single query, that's it. You have a snapshot in time. If you want like automatically refreshed results, listen. But if your app isn't running, you obviously can't listen. You need a process with a socket open, right? So it depends on which method you are using to query the database. So, you behind him? Yeah.
I'm a big fan of immutable infrastructure, and I have to go into the Cloud Functions dashboard and clicking a checkbox. Is there at any point in the future plans to add the retry on failure to the API?
Yeah, so you're asking specifically about that going into the Cloud Console and checking the retry box. Yeah, so yeah, so it turns out I was upset about not having retry on failure, and I actually proposed this as a feature request, and someone went off and implemented it, and then they didn't commit it to the main code base because they figure this is too much of this is a more advanced configuration. We don't want developers accidentally enabling it without understanding what it will do, because if your functions aren't idempotent, you can end up some really terrible side effects. Well, it turns out I was kind of mostly right on that, and I think they are going to go back and add retry on failure as a configurable option. But yes, today, right now, if you want the retry on failure behavior, you have to go into the Cloud Console and check that box. Or you have to use gcloud to deploy. So you can use gcloud to deploy functions, but you can't use the Firebase SDK to write your functions if you do that. So those are your only other options. Sorry. Yeah.
The API that you use translating, the same API that Google Home uses to ask it. I know that when you firmware update, that allows you to directly translation. Is the same like the same API?
So Google has its own, I don't know. Now, typically what happens is there's a public, like a consumer or a developer-facing API, and then Google has its own internal stuff. It's probably powered by the same ML that determines, like it would be silly to have two completely different systems. But I don't know if Google Home uses the developer-facing APIs. But I have to imagine it's the same infrastructure behind the scenes. I'm guessing, so, yeah.
Do you have any plans to have a more accurate cost modeler? I used to use it a couple of years back, and suddenly the billing changed, and all the prices went out of whack. And there wasn't a good way to figure out what your cost would be based on users and transactions. How do people deal with that?
So the questions around cost modeling. The only thing I'm aware of right now is the Firebase pricing page has sliders that let you guess what your traffic and load is going to be, and you can figure out the cost from that. The cost should be pretty straightforward. But if you're confused about something, come and talk to me afterward. And I think we're out of time. I've been given the signal. So all right, thank you everyone. If you have any questions, let me know.